All right, guys, we're going to talk about the very basics of graphing y equals 1 over x, which can also be written as f of x equals 1 over x. Okay? So just a few key points by the end of this. You should be able to find the vertical asymptote and understand what that means. Find the horizontal asymptote, know what that means, and understand the basic shape of 1 over x. Okay? Those are the three main points, and by next class, you should be able to do some transformations, something we've done in the past. So let's get started. First thing is just y equals 1 over x. We're going to use some basic numbers, and for example, -2, -1. We'll talk about 0 a little bit more later, 1 and 2. Hopefully you guys see why this is a problem with 1 over x, and we'll talk about it, what's going on in a little bit. So if we plug in -2, we get 1 over, and instead of x we replace it as -2, we get -1/2. In other words, when we plug in x equals -2, we go down 1/2. I plug in -1, well, I'm going to get -1. Okay? I plug in 1 over 1 equals 1. So as x equals 1, I'm going to get +1. When I plug in 2, I'm going to get 1/2. So x equals 2, y equals 1/2. Okay? So something's going on both sides of the y-axis, and so we're going to talk about that in a little bit. But first of all, let's talk about what's going far to the right and far to the left. So we already plugged in 1 and 2, and we're going to talk about as we keep going towards positive infinity, or bigger and bigger numbers as we go. So we'll go 1, 2, 4, 6, and 10. We'll just pick these x's. So we already talked about when we put x equals 1 in, we got 1. Okay? Remember, it was 1 over 1. When we put x equals 2 in, we get 1 over 2. Realize we're always going back to this. When x equals 4, we get 1 over 4. 1 over 6, 1 over 10. We already talked about before, or graphed, that if we plug in 1, we got 1. When we plug in 2, we got 1/2. When we plug in 4, this is new, we get a 4th. When we plug in 6, I get a 6th. And when I plug in 10, it is so close to 0, but not quite there. So what's happening is as we approach, as we go to the right, this will get less and less and flatten out. I should not have hit the x-axis, but it's going to flatten out that way. Okay? This is what's called a horizontal asymptote. What's happening is it gets closer and closer to 0, but it actually never will reach 0. You can try thinking the biggest x value you can, and you'll never get 0. What's happening is it's going the same on the other side. So if I plug in -1, -2, -4, -6, -10, we get -1, -1/2, -1/4, -1/6, -1/10. Okay? Which means I get -1, -1, -2, -1/2, -4, -1/4, -6, -1/6, and I'm running out of room, but -10, same thing. So from this side, looks more like that. Okay? So from both sides, what's happening is we have a horizontal asymptote. And we call this horizontal asymptote at y equals 0. We signify that horizontal asymptote with a dotted line, which means as I go towards far to the right, or if I go really far to the left, bigger numbers or really, really small numbers, I'm going to flatten out at this horizontal asymptote. And so what we have is something that looks relatively like this. Flattening out from both sides. There's our horizontal asymptote. Now, what's happening between the -1s? Because we plugged in -1 and we plugged in negative and +1. So for our purposes, we'll go -1 and +1. Figure out what's going on in between. Now, 0 is a problem. When we put 1 over 0, it's undefined. undefined, which we also symbolize this with the dotted line. Okay? So we plug in -1. Let's plug in -1/2. Let's plug in -1/4. And that might be enough on that one. If we want to sneak something in, maybe I'll sneak it on the other side. From the other side, we'll go 1/2. We'll go 1/4. I'll go 1/8. So I keep on getting closer and closer to 0, but I can't actually plug 0 in. So if we plug in 1 over -1, we get back to here. Sorry, that's wrong. We get here. Okay? And just realize this is -1. If I plug in -1/2, this is what I end up with. 1 divided by -1/2, which actually equals -2. So when you go over -1/2, you actually go down 2 on this one. Okay? Same thing, I plug in -1/4, I get 1 over -1/4, gives me -4. So as I get to -4, I am all the way down here. I can keep on doing it. If I go 1/8, -1/8, I keep on doing that. So what's happening is this side, as it approaches from this side, is going down there. It'll never cross that asymptote, that vertical asymptote, but it gets closer and closer. Same thing is happening from the other side. I plug in 1, I'm going to get 1. I plug in 1/2, I'm going to get 2. 1/4, 4. 1/8, I'm going to get 8. So from the other side, plug in 1, I get 1. Plug in 1/2, I get 2. Plug in 1/4, I get 4. Plug in 1/8, I'm off this scale, or off this graph. I end up with something that looks like that. So from both sides, whether I approach from this side or I approach this side, they go towards infinity. They just get bigger and bigger. They keep on going up. This is our vertical asymptote. It turns out the equation of our vertical asymptote is x equals 0. This is why it's a vertical line. A simple way of figuring out where your vertical asymptote is when the denominator is equal to 0. That's where our vertical asymptote is going to be. Now, if we put this all together, okay, our basic numbers, I plug in 1, I get 1. I plug in 2, I get 1/2. I plug in 4, I get 1/4. 1/6. I figure out, oh, what if I plug in 1/2 here? Well, that's going to be up to 2. Plug in 1/4 up here. 1/6 up here. So what happens is this is generally what it looks like on the right side of the graph. On the left side, I'm just plugging in all the same numbers except negatives. So the left side is going to look like this. Okay? Things to keep in mind when you're graphing this, we are going to ask you, to write the equation of the horizontal asymptote. So as this goes across with our dotted line, that's our y equals 0. As I come down with my vertical line, that's x equals 0. Okay? That's going to be our basic graph. Be ready to graph with transformations next.